Hello everyone, my name is Zhang Shuhan, and now I will give the presentation of my final report. And my report name is Brain-Machine Interface, which is also called Brain-Computer Interface, and shortened in BCI or BMI. And first, I will talk about the background information. First, the concept of brain-computer interface was proposed very earlier, but due to the level of science and technology at that time, human research on the brain, especially on neurons, was insufficient, resulting in the inability to conduct in-depth research on the brain-computer interface. And since the mid-1990s, such knowledge gained from the experiment has grown significantly based on years of practice in animals experiments. Early non-invasive devices for human use were designed and manufactured to restore damaged auditory, visual, and limb motor abilities. And the first experiment in 1990s confirmed that the neurons in the cerebral cortex can control robotic arm. And there has been a lot of interest in the study of inner brain interface. And nowadays, brain-computer interface are widely used in the field of neural repair. And next, what is BCI? The device where the brain exchange information with external device is called a BCI. Such devices need to be directly or indirectly connected to brain neurons. So there are two types: invasive BCI and non-invasive BCI. And both invasive and non-invasive BCI are serving people with dysfunction, helping them improve their quality of life, and providing them with more treatment options. And now I will talk about the non-invasive BCI. The different types of BCI are distinguished primarily by the physical connection between the device and the human brain. Non-invasive BCI mainly enables the exchange information between the brain and external devices through EEG technology. EEG is a physical method used to record the electrical activity generated by brain through electrodes placed on the surface of the scalp. As early as 1992, Hamsberger used the EEG technique in his paper to evaluate neurologically disorder and study brain functions. Between 1991 and 1997, scientists developed how EEG could be used to decipher ideas or intentions. But the resolution and reliability of the information that spontaneous EEG can detect are limited by the large number of electrically active neurons and the complex space of the brain. Therefore, it is very difficult to identify a specific signal in this complex environment. For example, eye-ticking signals are firmly locked in the brain, so the EEG is difficult to detect from the scalp. In the past, obtaining high-precision EEG signals mean more expensive equipment, but in recent years, clinical studies have gained detailed knowledge of EEG signals. And next is invasive BCI. Invasive BCI is based on probing the activity of a signal collection of neurons or multiple neurons. The study oriented in the 20s and actually in the 60s, when Dr. Fees and his colleagues conduct pioneering studies in which Dr. Fees demonstrated that monkeys could control neurons in the cerebral cortex to carry out spontaneous activity. Later, Edwards proposed that autonomous motor instruction can be extracted from primitive cortical neural space and applied to prosthetics. At this stage, with the continuous improvement of invasive microelectrodes, advanced signal processing, and neural decoding method, invasive BCI shows the unprecedented advantage of non-invasive BCI. We also mentioned earlier how non-invasive BCI works, and the biggest problem with the techniques that the EEG signals is taken from the surface of the skull, which isolate a large portion of the signal of our brain. So the signal on the surface of the skull become very weak. Secondly, because different areas of brain will work together at the same time, a large number of noise will be generated on the target signal, so causing interference with the signal recognitions and processions. In order to improve the resolution of the signal, the scientists use an invasive BCI. And next, I will talk about the engineering development stage. First, the BCI usually based on the cortex base. The study of motor cortex study are quite numerous. In invasive BCI, interference has been able to control three-dimensional movement of robotic hands, wrist orientation, and finger grip for several years. There are many reasons why process has been rapidly developed. The two more obvious ones being the follows. First is encoding of motion by neurons is relatively simple. We can also say that the encoding itself may be complex, but we can use a linear approximation to get a good enough result. So that can reducing the cost of research. A more important point is that motion has a direct corresponding good output, so we can directly use the output to compare with the neural signals to determine the correspondence between the movement and the signal. The opposite is true for the sensory cortex, where we can only study the change in the neurons themselves, and the monkey itself does not tell us how it feels, so it is very difficult to correspond. So usually we assume that if the external stimulus is consistent, the sensation is constant. And next is the visual cortex-based studies of BCI. Research on visual cortex is also very popular, but mostly widely known study should be itself byproduct, which is called convolutional neural network. After all, after big news of AlphaGo, there is a high awareness of this atom in East Asia. And next, the development stage of BCI. When it comes to process of brain-computer interface research, it is necessary to know some basic brain science knowledge and the history of brain-computer interface development. We have known that frontal lobe of the physical base is the most complex mental activity of human beings, and its main functions are to plan, regulate, and control the mental activities of human beings, especially speech and smell. So how do we know the different capabilities that correspond to these different brain organs? It starts from the very beginnings with fMRI, which is called functional magnetic resonance image. We all know that we all know the X-ray and CT in the hospital. Sorry. And now use fMRI to generate image of the brain. We can record brain activity only from the outside of the brain. The area of the neuronically active areas of brain. Because of the high-speed flow of blood to transport oxygen to the neurons of the brain to keep the neurons active, the functions of the different areas of human brain are inferred. However, the MFRI technique has many problems, such as high monitoring latency and poor accuracy. Not to mention the impossibility of reading neural information from these activity regions. In order to solve this problem, scientists has come up with the next generation tools, which is EEG. The EEG is talked in the previous slide. So EEG is mainly used to detect some brain disease. For example, there is a unique pattern of EEG imaging in epilepsy patients, and brain cells population activity recorded by electrode is a result that can help express the diagnosis and treatment of epilepsy. The problem of accuracy is not good here. One EEG electrode can monitor billions of neurons, but this accuracy is very poor, not much better than MFRI. And the delay is still in order of seconds. A further tool is cortical electrograms, where the electrodes are placed under the skull and directly touch the cerebral cortex. The technique reduces the physical distance in space to 1 cm and in time to 5 milliseconds. But it still does not solve the problem of too many neurons and not enough monitoring accuracy. In order to solve the problem of accuracy, the concept of local field potential was proposed, which is 4 times 4 mm chip device with more than 100 microelectrodes, through which information about the surrounding neural current is collected, thus improving accuracy. But this is not enough, so scientists have used membrane clamp techniques to access the cerebral cortex based on LFP, which is local field potentials. So that they can access individual neurons and can record the voltage difference of individual neural cells to read the information. And of course, reverse interference simulation of this nerve. The current human explanation up to this point is only the beginning of the development of BCI. In 1969, the scientist Abraham connected a monkey's neurons to a dashboard and then gave the monkey a banana reward by giving the neural feedback on the change of dashboard value. Eventually, after training, the monkey could control the dashboard through its neuron to get the reward. This example shows that neurons are plastic, and we can use feedback mechanism to allow neural and external device to be connected and controlled. This is actually the world's first brain-computer interface experiment. Later on, through the continuous development of computer science, there are more and more application sensors for motor cerebral brain BCI. The most classic example is in the 2014 World Cup in Brazil, where a teenager with a robotic skeleton controlled by the brain tried to get up from his wheelchair and take a few steps forward to kick off the World Cup. Another example is a brain spacemaker, which scientists has been studying and using for more than 10 years. It is used to reduce symptoms of Parkinson's disease, such as tremor, rigidity, and motor retardation by placing electrode into the brain of Parkinson's patients and implanting pulse generator under the chest, and then use the generated high-frequency electrostimulation pulse to surpass brain over-excitation. Of course, besides Parkinson's patients, there are many other types of brain disease patients, such as autism patients, Alzheimer's patients, and depression patients, and so on, whose treatments are all different and need to develop of brain scientists to support and solve them. Neural signals are very complex, and this has become one of the core problems in the field of brain-computer interface. How can we select only the part that is relevant to the task at hand. When the neural signals are all encompassed, including the subject motions, movement, sight, and sound, and etc. For example, for specific brain-computer interface tasks such as a brain-controlled robot or a brain-controlled mouse, only the neural signals that control movement are what we want. So how can we filter out other irrelevant neural signals and control the neural not to think? A common solution to the above problems is to use only neurons in the primary motor cortex, which, as the same implies, should be highly relevant to motor control. That's true, but the problems is in the fact that this part of neuron is not only relative to motor control, and the effect of the word more than makes it more difficult to achieve stable, fast, and accurate motor control over time. Always, the previous approach is probably equivalent to the steam engine before the invention of the governor, which is a great technological advance but not a meaningful engineering project. With the development of computer technology nowadays, artificial intelligence, which is called AI, is becoming more and more mature. And for highly coupled complex system, AI is demonstrated tremendous capacities. And we know brain-computer interface is an engineering project that involves brain surgery, neuroscience, and mathematical science, microelectrode, clinical trials, computer software, computer hardware, and network communication. And therefore, in recent years, scientists have generated brain-computer interface with AI technologies and has done a lot of scientific experiments. Current AI is divided into two main research directions. One is machine learning based on big data algorithms, deep learning, and other is biological neural stimulation implementation based on human brain research, such as impulse neural networks. Studies in the brain can help people find implementation of AI algorithms that are more in line with the human brain. For example, many current machine learning algorithm implemented model that require training based on a large amount of data. Well, the human brain can achieve the same capacity with a very small number of data sample and achieve corresponding recognition judgment. Training to recognize the cat with machine learning may require tens of thousands of photos of cats and other animals and constant optimization, but the human brain can accurately recognize the cat photo with a very small number of sample. And the CEO of Tesla of SpaceX has required Neuralink, a company that aims to establish a direct link between the brain and the computers. With the rapid development of technology over the past few decades, the line between the humans and the machine began to shrink. With the help of machine, the spectacular mind-controlled world of science function are slowly moving close to reality. Currently, at the forefront of these new technologies are BCI and AI, although BCI and AI are used to develop and apply independently for each other. However, a growing number of scientists are now looking to combine these two to make a process of manipulating external devices with EEG signals more efficiently. Currently, the concept of human AI is used in many the concept of AI. And next is a post-development state of BCI. First, we are talking about the development stage. Over the past 2 decades, many national laboratories has been conducting research um, on brain computer interface, realizing a variety of programs and application models. Brain computer interface where both parties interact with each other with the purpose of wanting to change the state of the other. Brain computer interface system in which the brain is an intelligent system in the biological sense and the machine is a physical world artificial intelligence systems integrate together constitute synergetic intelligence systems. In order to give you an overview of the current state of brain-computer interface development in a short period of time, the various applications are categorized here in 3 areas, namely interface, interaction, and intelligence. First of all, we are talking about the interface. Literally, is link of two devices, two concept or two system to achieve what is now called interconnection. What can be done after the brain and the machine are connected? In the initial stage of brain-machine interface, one of the brain motivation was to provide external communication opportunity for people with motor disability. So many laboratories have developed system to control a wheelchair system nowadays. Some labs have also developed system for controlling prosthesis and exoskeleton in 2014. The example that I mentioned above, the paraplegic person kicked the first ball out of the Brazil World Cup using EEG signals, and now such control system can be continuous control even with non-invasive technology. Regarding interactions, it emphasizes interaction between the brain and the machine. And the purpose of interaction is to change the state of other. In the brain-machine system, the brain is trying to change the state is trying to change the state of the machine and control the external device to achieve a certain action. In fact, the machine is also trying to change the state of brain based on the obvious plasticity of cerebral cortex, which, given certain information of training, can change the way neural network of the cerebral cortex are connected. And it also can be used in the future to imagine the damage of disease or to improve the cognitive ability of people in healthy population. Brain-machine interface are very important in the field of rehabilitation application. Stroke is a very common disease that often leads to a lot of side effect. In this case, the cortical layer of the brain that governs the movement has been damaged, and hospitals have probably used rehabilitation robots to help patients move their legs and feet, but this is not very efficient. However, this is not very efficient because damage is to the cortical motor center of the cerebral cortex, and moving only the arms and legs is not very effective. Therefore, another activity training method has been developed based on brain-machine interface, which is to let the stroke patient imagine the movement, and when the patient imagines the EEG signals responsive, so that the EEG system can measure can activate the training the robot so the patients really want to move. Studies have shown that this type of active training is very effective. Next, so about intelligence, brain-computer brain-computer interface collaboratory intelligence contains two kind of system. One is the intelligence system in the biologic sense, and other is the intelligence system at the physiology machine level. As we all know, compared with the human intelligence system, the current level of artificial intelligence system is much worse. In this case, the research direction of artificial intelligence can be divided in two paths. One is to continue the research and make a particular smart robot. Another is that since people are smarter than the machine now, so simply invite people to conduct research together. And next, I want to talk something about the application areas as a at as a multidisciplinary and emergency communication technology. Most of the research on BCI is at the theoretical and laboratory stage, and there is still a certain distance from the practical application. However, in terms of its performance, BCI system and its technology will play important roles in many fields involving the human brain, especially for the restoration of capacity and functional training of patients with severe mobility defect. Currently, research on BCI application is focused on the following areas. The first is the aim of type research to improve the ability of patients with languages loss. And secondly is environmental control. Research on environmental control of the BCI is mainly based on virtual reality technology. Virtual reality is a relatively safe and mobile target that provides a safe and secure environment for training and adjusting neurological activity. And the third is a BCI system detect and classify the EEG signals and then output the command to the neural processes to perform the function of neurons that have lost their functions, or output the command signals to the command receiving system in the wheelchair to perform the function of movement and such as walking. And finally, the initial application of BCI shows that on one hand, it can be used as a adjunctive therapy for restoration of motor or speech functions in patients with disability, especially those who have lost motor or speech functions, but those whose brain functions remain instant. In order to improve the in order to improve the quality of life of patients, on the other hand, it can be used to hazardous environments or in environments that are harmful to people to replace the human limbs to complete certain operations. And finally, I'll talk about the future improvement. The signal processing and information conversions speed need to be further improved. Currently, the maximum information convolution speed of BCI can reach 68 bits per minute, but this is far from the requirements of real-time control. Improving the information processing method to extract the signals with the required feature from the original signal of the great importance in BCI technology. The improvement in the accuracy of the source signals extraction facilitates the classification of signal, and the improvement in the speed and accuracy of BCI system. The improvement of signal conversion speech is a combined result of improving signal processing methods, signal convolution algorithm, patient training method, and other factors. The second factor need to be approved is accuracy. Although the current rate of the BCI system in the laboratory research stage is better than that of random guess, it is still far from needs of practical application, and the feature signals extraction and classification techniques of the BCI cannot fully reflect the patient's thinking activities. Accuracy is a result of combining effect of various factors such as degree of training of subject, the method of signal analysis and processing, and accuracy of classification and recognition result, all affect the accuracy of the output. The third things need to be improved is there is still a gap between EEG detection technology and practical requirements. In terms of EEG detection, there is no definite conclusions as to what kind of signal is needed and what kind of detection and processing methods should be adapted accordingly. The current EEG detection technology, whether with built-in electrodes or non-built-in electrodes or caps, is only suitable for laboratory research application and requires assistance to complete. The actual BCI application system need to be enable patients to independently control the external environment and achieve communication between patients with functional defects and outside world without assistance. In order to bring BCI technology out of laboratory and truly meet the needs of patients with functional defect, a lot of research needs to be done in EEG detection technology. And finally, development of the application area at present, the research of BCI technology is still in the theoretically and laboratory stage, and has not been applied to patients on large scale. With the continuous development and improvement of BCI technology, it is necessary to develop new application areas, and it is an inevitable trend for BCI technology to develop practical and integrated BCI application system by combining various technology and different application areas with each other. Finally, I will talk about the challenges. The first is technology challenges. It has been 15 years since the concept of BCI was first proposed by Jacques J. Vida in 1973. BCI is different from the traditional device that interacts with the organism. It is a device that exchanges information between the living brain and the device, and is a bridge between the biological brain and the device for information exchange. Currently, EEG is the most used signal source for BCI. The two most important steps in BCI are the decoding strategy for extracting and identifying EEG features, and the other is to convert the extracted signal into the concept through the patients to drive the work of external device. The first things the first things that affects the work of EEG is the signal acquisition rate, which we mentioned above, and the second is accuracy of the EEG. and then it's ethic and the legal challenges. BCI need to collect information from the brain and record analysis. In other words, BCI need to read the patient's thought. So this involves privacy issue. No one can guarantee that data will not be stolen by hackers and applied to illegal territory. and the invasive BCI require electrode to be installed in the brain. Long-term running of BCI device may cause local structure change in the brain, which in turn affect the patient's mood and even change the patient's personality and behavior. In addition, with the inventory of technology, perhaps in the future there will be a device where the human brain and external device can exchange information with each other, rather than the current BCI can only transmit brain signal to outside. Perhaps the future external signals can also be transmitted to the brain through BCI. Artificial idea artificial idea become possible, causing serious ethical problems. 2 years ago, Elon Musk built a platform that can be implement electrodes to more than 3,000 and develop a robot specifically to help implant electrode into the skull. Trauma can be done very small, but because it is completely self-developed robotic device. But how to take out the neural information of these channels after the electrode goes in? For this, he developed a custom chip to digitize the collected data. Finally, of course, the neural signals need to be analyzed compared to existing platform. This is a big step forward in technology. Less than 2 weeks later, Facebook also announced their latest research on brain-computer interface using the activity of humans' cerebral cortex to decode the concept of question and answer conversation in real time. So this is also a violation of privacy, of personally privacy. So this is all challenges of the BCI. And thank you. This is everything in my report.